In this video, we'll be covering 2.6. Basically, we'll be continuing to look at proofs and even more so into geometric proofs. We'll also look at a few different types of proofs. First, we've been doing two-column proofs, which would be this first one here. But we'll also see flowchart proofs, which is basically, we're still proving the same exact problem, it's just a different format. And then also paragraph proofs. Again, still proving the same problem, still trying to work towards this proof, but it's just in a different format. But like I've said before, we will be using the two-column proof typically, but there will be times where you'll see these other two formats. So in continuing in proofs, we always are building on our theorems, or building on our postulates, things that we know that are true, that we can use in order to prove something. So in this case, we're proving, we have right angles congruence theorem. It just tells us that all right angles are congruent, which would logically make sense since right angles are all 90 degrees, they would be congruent. They would be the same size and the same shape. So in example 1, it wants us to use a flowchart proof to write a two-column proof of the right angles congruence theorem. So they've already given us this proof here, the flowchart, and then we just need to rewrite it in a two-column. So if you look at the original problem, we are given that angle 1 and angle 2 are right angles, and we want to prove that angle 1 is congruent with angle 2. So basically they have given us the steps already. We just need to put it into our two-column proof. So if I start with my statements on the left and my reasons on the right, I'm going to use this flowchart proof to just fill it in basically. Okay, so we know we start with our given. You look at this first step in our flowchart. That's going to be our first step in our statements and reasons. So if I have a 1 and a 1 for my statements and my reasons. Then the second step is going to be my 2. So when I get there, I'll lay my 2. This will be my 3. And this will be my 4. I'm basically just putting it into this flowchart, just showing how they are related. So my first statement just says angle 1 and angle 2 are right angles. Basically, the bubbles are going to be our statements. Okay, the bubbles is going to be on this side, the part that's bubbled in over there. And then our reasons are going to be the part underneath, so the part under it. So in this first one, my statement, I have angle 1 and angle 2 are right angles. My reason for this is that it's given. Then I can move to my second one. So my second one is just, again, once in the bubble. So my bubble just shows me that measure 1 is equal to 90 degrees. And then measure angle 2 is equal to 90. So I have measure angle 1, measure angle 2 equal to 90. And this reason is going to be what is underneath, basically the definition of a right angle. Okay, they told us that 1 and 2 are right angles. Definition of a right angle means that they are 90 degrees. So I have definition of a right angle. Then my reason 3, or my statement 3, is going to go back to my flowchart where we have that 3. So measure of angle 1 is equal to the measure of angle 2, like so. And then my reason is going to be the part underneath again, which it tells me is transitive property. Transitive property, remember, it's a lot like substitution. The only thing is substitution is typically when we are dealing with a variable. Transitive property is just making the connection, basically taking out the middleman. Okay, so since measure of angle 1 and measure of angle 2 are both equal to 90, we can just take out that 90 and go ahead and plug in that they are equal to each other. And then we would move on to our statement 4, which tells us angle 1 is congruent to angle 2, and then also our reason. Our reason is definition of congruent angles. If angles have the equal measure, then it means those angles are congruent, because they already have the same shape. Okay, angles are always shaped the same way, just they can have different measures. And so if their measure is equal, then they are also congruent. And so you can see I wrote here our reason, definition of congruent angles. And so this was what it would look like if we took this flow chart and all we did was change it into this two-column proof. Okay, we were given this information, we could just change it over. So then we have some other theorems to look at as well to add in this section. We have congruent supplements theorem. Congruent supplements theorem just tells us that if we have two angles that are supplementary with the same angle, then that would mean that those two angles have to be equal. They have to be congruent. And then we also have congruent complements theorem, same exact thing. If we have two angles that are complementary to the same angle, then that would mean those angles have to be of equal size. And we will be looking at examples with these. So in this problem, we're trying to prove congruent supplements theorem. We're trying to show how it works. Originally, this problem, it already gave you the two-column proof and you were to write a flow chart. But like I said, we typically write two-column proofs. So instead, we're going to go ahead and just look at this. We're going to make our two-column proof. Okay, so the beginning of this question, you can just ignore. Basically, we want to prove instead that two angles supplementary to the same angle are congruent. So we're going to start with our T-chart. We're going to start, we have our statements versus our reasons. And actually, I'm going to make this bigger because we're probably going to be doing a lot of writing. So we start off always with our given. So we have angle 1 and angle 2 are supplementary. And I'm going to abbreviate it. And we have angle 3 and angle 2 are supplementary. Okay, this would be like our statement of 1, in which I didn't really leave enough space, but this would be 1. So our first reason is going to be that these are our givens. Then we're going to move to our statement of 2. Okay, we're trying to work towards this proof. This proof here that says that angle 1 is congruent with angle 3. Okay, so when we look at this, we need to try to work towards that proof. So if we're trying to prove this, one thing to remember, proofs is a lot of trial and error. You can write a statement and a reason and maybe never even use it, but you want to try to build information so that way you can prove your case. Okay, it would be better to have too much than too little, otherwise you may never actually get there. So if we start off, we know that angle 1 and angle 2 are supplementary. So think about what that means to you. Okay, supplementary means 180 degrees, so it means that those two angles have to make 180 degrees. Well, they're not, we don't know if they're just both 90, we don't know what their measures are, but we do know that they would add up to be 180, so we would want to write out that statement. So we would know the measure of angle 1 plus the measure of angle 2 would equal 180 degrees. And we would know this based on the definition of supplementary angles, or just supplementary. We would also be able to say the same thing for the second one. We have angle 3 and angle 2 are supplementary. It would be the same exact definition, so I'm going to leave it on this second statement, but I'm going to write that one out as well. So I would have the measure of angle 3 plus the measure of angle 2 equals 180. Same reason, it's still there on statement 2. So if we're trying to prove that they are congruent, think about these two together. Because we start off with two statements, but we're trying to get to one, just that angle 1 is congruent to angle 3. Well, look at these two statements. They both are equal to 180 degrees. So we can eliminate, like I said, that middleman and go ahead and set them equal to each other. So our third statement could look like measure of angle 1 plus the measure of angle 2. Instead of it equaling 180, I can equal it to my second one there and combine them. Okay, because if they're both equal to 180 degrees, then they are equal to each other. And this again would be our transitive property. Okay, it's a lot like substitution. It's just when we see something's equal to the same amount, then we can equal it to each other. So now I can look at this statement. Notice the angle 2 is repeated in both. It's added to each one. So if I were to subtract the measure of angle 2 from each side, it would basically just disappear. And I would get the measure of angle 1 is equal to the measure of angle 3. And this would be subtraction property of equality. I subtract the same amount from both sides. And so now you can see it looks similar. Okay, we have the measure of angle 1 is equal to the measure of angle 3, but we wanted to prove that angle 1 is congruent with angle 3. Well, based on congruence, if angles have the equal measure, then they are congruent to each other. So my last step is going to be that angle 1 is congruent to angle 3. And then my reason is going to be the definition of congruent angles. And so this would be our two-column proof. Notice we got to where we could say angle 1 is congruent with angle 3. That goes back to our proof, so we finished. Remember that this is our answer. This entire proof is our answer, being able to have those logical statements that lead up to what we are trying to prove. So we have a few more postulates that we need to look at. Linear pair postulate. So linear pair postulate just says the same thing like we know linear pairs are on the same line, and since they're on the same line and a line's measure is 180 degrees, then they would add up to equal that 180 degrees. If I add angle 1 and angle 2 in this case, it would equal my 180. And so it's just telling me, so in proofs I can use that. Okay, if I know they're a linear pair, I can use this information. Then also vertical angles. Vertical angles are made by our two lines that intersect. So here we have two intersecting lines. And their opposite angles, okay, ones that are opposite of each other, are the ones that are equal. There are vertical angles. And so in this case, we would have angle 1 is congruent with angle 3, angle 2 is congruent with angle 4. And again, so we can use this information when we are trying to prove something. So let's look at this problem. We have proving the vertical angles congruence theorem. So using the given paragraph proof, write a two-column proof of the vertical congruence theorem. Okay, so angle 5 and angle 7 are vertical angles. So if we look at our picture, we have two intersecting lines, and we want to prove that angle 5 is congruent with angle 7. Okay, and they've given us this paragraph proof. Once again, this is another type of proof. We do not typically use it in this class, but it is good to be aware of it. And so we'll go ahead and go to the next slide and start working this proof out where we can have more space. So I have a smaller version of the slide up here on the right, and I'm going to start our proof on the left here. So in our paragraph proof, we can look through it and we'll start to identify each step. So the first one is telling us angle 5 and angle 7 are vertical angles formed by intersecting lines. Okay, so they're not necessarily giving us our reasons always here. This one takes a little bit more of pulling out the proof instead of the flow charts, how it just gave us our statements and reasons. This one, a lot of times we can use the order, but we may have to add some additional information to actually show it. So like this first one, this would be our first statement. Though it doesn't say it was our given, just because it's our first, it would be our given and our reasons. So as you can see here, I wrote out angle 5 and angle 7 are vertical angles. That's our first reason. It's going to be that it was our given information. So then the second one, it says, as shown in the diagram, angle 5 and angle 6 are a linear pair, and angle 6 and angle 7 are a linear pair. This would be a given. Because it's in our diagram, we just have to pull it out. The diagram was given to us, so this would also be given information. So we can actually include it on this first reason still. And so you can see in step 1 here, I just use semicolons to separate my statements. Okay, they're not the best because it's hard to draw on this, but I use semicolons just to separate them. So they can all stay on that same first statement because all their reasons are still going to be given. So I end up having angle 5 and angle 7 are vertical angles. It was my given. Angle 5 and angle 6 are a linear pair because it was in my diagram. It's a given. Angle 6 and angle 7 are a linear pair. Again, it's in my diagram. It is a given. Then if we look at the next sentence, it tells us, then by the linear pair postulate, angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary. So that's using our postulate. So that's going to be a new reason. So it need to have a new statement. So here I've written out my statements. Angle 5 and angle 6 are supplementary. Angle 6 and angle 7 are supplementary. My reason is going to be linear pair postulate. It told me then by linear pair postulate, these things are my statements, so that will be my reason. Then if we look at the last sentence, it says, so by the congruent supplements theorem, angle 5 is congruent with angle 7. If you look back at congruent supplements theorem, it basically tells us if two angles are supplementary, then those two angles are congruent. So that is why we can go ahead and just skip to that step, because we use that postulate as long as we use it in our reason, we can actually use it to our advantage, so we have less steps. And so I wrote my last step here. Now, like I've said before, statements our proofs, our statements and our reasons and our proofs aren't necessarily always going to be exactly the same. There are variances in what you can do. This one would be one example. Like we went ahead and used congruent supplements theorem because they told it to us in our proof paragraph. But if we had instead written out that the measure of angle 6 plus the measure of angle 5 is equal to 180, and then written out the second one, measure of angle 6 plus the measure of angle 7 is equal to 180, we could have used like that previous one that we did where we did transitive property, and we actually wrote it out, and we showed that their measures are equal, and then we showed that they're congruent. Okay, that would have been acceptable as well. It would have been more work, but it is acceptable. So it's to your benefit if you know these theorems, if you know these postulates, you can skip a lot of steps. If you don't, then those steps would need to be in there in order to show it. Being able to say something, like if you had some other reason here for number 3, instead of congruent supplements theorem, but yet you had still skipped to say that angle 5 is congruent to angle 7, then it wouldn't have been correct. If your reasons and your statements don't line up, if your logic doesn't add up, then it is incorrect. But as long as you are using these things, using them correctly, then there are many different ways you can write these proofs. And we will be working on them in class, so please don't be discouraged, but continue to work on them and continue to get better. The only way you will get better at them is by practicing them and by trying to practice them so you're seeing them in place and these things become familiar to you.